I'm going to be doing a very hands-on thing because, I mean, it's not because I didn't prepare any slides at all, but actually because I wanted to take an opportunity to play with stuff that we usually don't do. I wanted to play with a core, I wanted to take a look at some code, and I'm just going to stash some stuff. Okay, so I have prepared the entire branch ready with all the code. We've done this at a different, you know what, sorry, should be using microphones here. So, here we go. Okay. So we did this at a different DancerConf, and it was really, really nice. We just went over the code base, we opened it up, we looked it up. It was a lot of fun. And I think it's interesting because we get to see stuff that we usually don't talk about, that we don't see, which is just like gnarly details of implementation. And usually when we show code on screen, we only show the really nice stuff that we cleaned up. And it might still be terrible, but it's much nicer than what we started with. And I wanted to do a completely different thing where I actually go over the gnarlier details and give you a basic overview of how the core is actually implemented. And this might make you gasp, scream, but more likely it will just be like, oh, okay, that makes sense. And if that means that after that you might actually tweak something, improve something, or even work on a feature or fix that you wanted to do for a while, then hey, now you can do it, and it's not that crazy. So I have, how much time do I have? Is it 50? Is it 30? Is it, does anyone have any idea?
I think 3 minutes.
Okay, cool. So 3 minutes. I'm just going to talk until someone goes, okay, that's about it. And feel free to ask questions throughout, because that's what we're going to do. Does anyone remember this? There used to be these TV shows where people went into the human body and kind of went through everything. There were like 7 of these. One of them had a bus. And I like that idea because I was too old for the bus thing, but I like that idea of going through the human body and seeing everything from inside it, and keep your hands inside the bus or whatever vehicle they're in. In Futurama, it was a spaceship. And I want to do the same thing with the core. So I'm going to give you an overview, but then we're actually going to crawl through the dancer body a little bit so you can see how things actually come together from a basic use dancer 2 perspective. So I hope that works out, and I'm gonna try and do it. I'm split screening here, so we'll see if that works. So I'll start with the structure you're seeing ahead of you. I figured this would help. Of course, I figured this out right before going to sleep, but I think this would help just to kind of give an overview of the biggest or the most important component in Dancer, which is actually what's called the app, the Dancer app. And whoever was in the training yesterday, we were talking about the difference between web applications and Dancer apps. They're not the same thing. And the reason is that a Dancer app is actually an object of Dancer 2 core app. We try to separate all the internal details into a namespace Dancer 2 core. And the core app is the biggest component, the most important component, which contains all of the context. There is a lot of context that happens during a request, or the cycle of a request. It used to be a long time ago. There used to be a context object, and we removed it because it was too coupled, and at the same time not too decoupled and too coupled at the same time. It was kind of odd. Some back references there and weird things that were very difficult. We might return it at some point, which I think we included in the commit message a long time ago. But meanwhile, we just basically moved all the context into the core app, and you'll see what I mean when we open it. What you have here is basically the core components of a core app. The first is that we have on the right, if I'll use my mouse, you'll see this, the core response. D2C is short for Dancer 2 core. It's the current response and the current request. The Dancer app at any given time has a response object and a request object. The request object contains the request that you received, and the response object, even though you didn't finish your code, it is built ahead of time and then populated throughout the program. And there are multiple reasons for this. It would be nice to build the response at the end, but you still need an intermediary step because some stuff gets built while you're running. So for example, if you're changing headers, that eventually will be in the response, but you have to store it somewhere until you're done. So we have a response object, which is the current response being built. And at the end of a cycle, that actually gets returned to the user. We have, on the left, all the routing code that you have. Every route that you define with get, post, whatever verb you want, if you use a prefix, it will tack that on when you build it, and it will create an actual route object, which is the answer to core route, and that will include the path for it, that will include the code that you have for it, that will include additional things. Yesterday I wrote a patch that adds naming to routes, so you can actually have a name for your route. And that's an idea that we had for a very long time. And yesterday, we've been hashing this out for a long time, and then yesterday I thought, I think I can make it work without changing too much. And then I wrote the patch. So maybe we'll see it during the conference being committed. So all the routes are actually stored in the app. So any given app knows the current request, the current response, all the routing code that it has to go through. There is toApp right over here, and the toApp is basically, it builds a router. It builds a proper PSGI app that is internally actually a router over all of these routes. And it actually tries to match all of these routes, and when it succeeds, it runs them. It also contains the current engines, the session that you're using, I have session twice. One of them is supposed to be a logger, I'm sorry. The session, the logger, the serializer, and the template, they're all stored within the app. And that's how each app has its own routing code. Each app has its own response, its own request that it can handle. Most likely it will handle only one at a time. Each one can have its own engines. Each one can have its own router internally. That's why you call toApp on each class separately. So this gives an overview. And what I actually want to do is start going through the code. So pause me when this is readable. Is this good? Can everyone read it? Okay, good. So what I want to start with is what happens when you just call use the answer to. I'm going to pause every few minutes so you could ask questions, but you should take that opportunity because otherwise I'm not going to pause. Does anyone have any questions before I begin? Is it almost easy. Okay. Maybe it's a nervous tick. All right, so I'm going to sit down for this. Okay, so when you have a piece of code that says use the answer to, what actually happens is that this loads the answer to class. The answer to class has one purpose, which is importing everything for your specific namespace. If we open the answer to class, there's a bunch of stuff here. The thing that matters is the import here. And the import here will have to not just import a bunch of DSL keywords, but it will have to create them. And we create them on the spot. And that's something that's a bit weird, but it serves a very important purpose. The first thing that we do is analyze all of the arguments that you send. There's some support for deprecated ones. There's support for ignoring all the pragma importing. It's a bunch of stuff that's going on here. We're using something called import into, which you can look up, and it's very useful for importing into other namespaces. And at the end, once we decide the actual app name, we will create a runner and a proper app object. So we have to create some kind of context to store all the information that your code will do, right? So when you're going to call get, that has to create a route that has to be stored in an app. So we have to create that app. If you're using app name, you don't fall in here, because if you're using app name, what happens is that when you specify use an answer to app name, we will look up if there is an app by that name, and we will grab that one instead. And that's how we utilize a single app in order to serve more than one content. The next part would be to export all the symbols, which happens on the DSL object. All of the DSL is actually defined within a core DSL object. You can see here all the DSL keywords implemented. These are their definitions. Is global here is not the best name, because what it actually means is, can you run this from anywhere, or do you have to run this from a specific route, from a route only? There's reason for it, because some things only apply within a route. They only apply within a request. They're not available outside of a request. If you want to render a template, you can do it at any point. But if we take into account forward, you can only forward when you have a request. So you shouldn't be able to call forward from outside a request. And we use this flag, so when we generate a DSL keyword and we put it in your namespace, it will also do a check and say, are you using this within a request or not? Because if not, I'm going to stop here. Because I can't run this, actually. There's no way, like, it won't actually take any proper effect. If we scroll down, you'll see the implementation of each one. Now, the most weird thing at first is that none of the implementation other than the session is actually in here. And there's a reason for that. There is a separation as much as we can between the definition of a keyword and the implementation of it. The implementation of it is usually elsewhere. In this case, the template is actually implemented inside the app object. The set is implemented by just calling setting. The setting just goes to the app, and so on. Session is a different one, where it tries to be a bit smarter. Send as, send error, send file, all of them go to the app. So we want to have this implemented elsewhere from where we define these. And the reason is simple. The DSL can have, is implemented within a role, which means that anyone can write their own DSL. An example of this was by Damien Kotkin, Dams, also a core dev, who wrote a DSL in French. So all the keywords were in French. He just re-implemented this class. Sorry?
You needed that.
Yeah, we need that. So he implemented this class, and then the send as and send error, he implemented as is, he just gave them a different name. And they still went to the app. So eventually he only had to write the stubs instead of writing all the actual implementation code. So there is a separation. Some things are a bit more complicated, and these should eventually also be moved probably. If I'll look for the, let me go back and open this, and the export symbols too. The export symbols too, once we create a DSL object, we have to export the symbols. And if I'll open the DSL object, you'll notice that it doesn't actually have it. This doesn't exist. Export symbols, sorry. Export symbols. It doesn't actually exist here. And the reason is, as I said, we tried to have the core of the DSL implemented in either the app or the role. So here's the role. So let's open up the role. And this should allow exporting any DSL that you implement into the caller. And this is how it does it. This is basically it. This is how we create DSL keywords for you on the fly and export them to you. It's kind of crazy. Construction of a map, construction of a keyword, and eventually it reaches this part, and this part creates a piece of code that calls the keyword, and if it's not global, then it will also put this check in to basically say you have to have a current running request. I haven't discussed this. It is sort of a global, but not really. So I will explain this later on. Okay, so what we actually do every time then, we create an object for an app, then we create a DSL. You'll notice that the app object, the DSL object will retain the current app that it was stored into. And this is useful. So basically all of the keywords that you get, they're not just general functions. They are made on the fly and they close over an app object. So when you call get, have you ever noticed you don't have $C for context like you do in Catalyst, Modulicious, a bunch of other frameworks? You don't have this because the only other way to do it is to have a global get. There's always one app. But in Nestor, there's multiple apps. So how do we do this? By not having a get context variable and at the same time not having complete globals. The way that it works is that when you call use and answer to, you get your own get, which is not just the general get. It is a get that is then closed over an app that is special for you. So it's a pretty crazy idea, but it actually works really, really well. So your get is your get. And if someone will call your namespace's get function, they will be able to register a get in your app, right? It is a very specialized DSL. It's a specialized keyword that only relates to the app that relates to you, or your namespace, which is really, really nice. And then we export them all over. And that's what Dancer2 PM does, basically. Create the app, create a DSL object, and ask the DSL object to then inject all of these keywords into your namespace. That's it. Now, going back to the DSL. All of these DSLs, when they call shift, they reach the DSL object. When they call app, they reach your app object. And then you can call stuff on it. So let's take a look at the app. Before I take a look at the app, does anyone have any questions? I'm gonna pause here. None at all? Really? Really? Okay. So let's dig further. Core app. Of course. So the core app is probably the hardest to process class that we have. It's not that insane, it's not that crazy, but it is big because it contains the current context. So it is basically a move class, so we get a bunch of attributes and all that stuff. And you can see here the logger engine and the session engine and the template engine, and these are all the things that I was discussing earlier that it contains. Each Dancer core app object will have its own engines. That's how you can have multiple classes that call use Dancer2 and they have their own template systems, for example, or they might have their own loggers, or one might have a serializer while the other one might not, because each one contains its own. So you can see here that each one is actually tested against a role. The role implements the core of it, so you can have multiple template systems, each one having a core implementation that sits in the role. Or, it could be also for validation of the classes, it could also be for helper functions. Let's take, for example, what happens to a template class. Template, and then let's say it's simple. Simple, it's a basic template. It was provided because we didn't want to carry a template system. We do carry support for 2 template systems, but we didn't want to carry one. Eventually we did write one, which was Tiny. And that's actually, is anyone familiar with Template Tiny by Adam Kennedy? Okay, so it's a very small templating system. It has very few features, but it's very, very, very thin. And when you don't want complicated things, it actually fits. It's very fast. And we had to eventually implement it differently. We had to edit the implementation a little bit because there was some issues with it. I don't remember which, but we carry our own implementation of it. Because it's so fast, you can see how, well, of course that won't work. It's actually fairly small. That's it. Like these regexes process everything, and that's how you get a very, very small, core. There should be an explanation here why we did this. These are all basic stuff. I don't remember why we implemented it again. I think there was some weird behavior that Adam doesn't actually develop much nowadays in Perl, so he's not there to support it. So and I don't think he wanted to change it, so we just said, okay, we'll have our own thing. It's basically a copy with a small change. So a template system that uses the role has an engine, and this is an override to the test of an engine. So it tests that an engine actually fits something that implements the fork Tiny. It doesn't matter that much, it's just implementation detail. The render function, which is the only function you actually have to implement if you write a template engine, gets validated that it exists by the role. So as long as you use the role, you're assured that we will test that you've done things correctly. One of the things that we will test is that you actually implemented a render. Because maybe you wrote one and you say, oh, this is going to be render template, because that makes sense as a subroutine name. But you made a mistake because we actually look for a function called render. So instead of waiting for runtime when it crashes, during load time, we will test this for you. And you're going to get all of these automatically because we make sure to call this with all the information. And all you have to do is just load your template and call process on it, or whichever way your template renders stuff. And that's it. This is very, very small because the majority of the code is actually implemented in the role itself. So let's take a look at the role. What does that actually mean? The role implements, first of all, it uses a basic engine role because the template engine and the logger engine and the session engine and the serializer engine, they're all engines. So we can take anything that is common to all of them and implement it together and make sure that all the roles for specific engines all adhere to the same behavior of an engine. Fairly simple. There are hook aliases, so each engine can define hooks, and each engine can define aliases for those hooks. So, for example, there is a full hook called engine template before render. But that's really long for you to remember. So instead, the template engine provides before template render. And that's it. And that allows us to provide another name for when we want to run this hook. We also run this name. We don't actually run both, we just copy one to the other. It's okay. This is the line that validates that you have a render subroutine implemented. Fairly simple. We provide a callback to login for you. You can have a name. The name is done automatically for you. You don't have to think about it. Char set, the character set, all the views, layout, all these variables that are very, very useful for you to have. We validate them, we create them. We also populate them. So you get all these for free. You get your settings hash for free. We will populate it as necessary. All the layout directory that you need, we're going to also specify it. We're going to populate it. You can change it if you want, but that doesn't make sense. We clean up the template name, the layout name. We check that things exist. You can see comments from implementation. It's kind of stuff that you won't put on slides, right?
Yeah.
And eventually, we're going to call the hooks. We're going to call your method, and then we're going to call the hook after for you. So you don't actually have to think of, oh, I actually want people to be able to run stuff after my template render. Don't worry, we got you covered. As long as you use the role, you get this for free. And we will apply the layout automatically. So we're going to call you again with the layout. Here, for example, you can see all the default tokens that you get when you call template. Because you're supposed to have tokens in your template. So we set up all of these tokens for you ahead of time. And if you call the before template hook, you can have access to this token hash and then alter it. So for example, we'll put the Perl version and the Dancer version. We're putting all the settings that you get into the templates. If there is a current running request, you can have the request, the parameters, the vars, you can have the session, and all of these are available only when there is a request. So it used to be that everything happened. So this used to be the code. Oh. And the code, when the code was like this, if you try to run template from outside a current running request, it failed because when we try to get a request data, it would say there is no current running request. I can't do this, and it would crash. Someone opened a ticket and said, I would like to be able to use template outside a request cycle. Because I want to render something at the beginning of an app, and I already have a bunch of settings for my templates, and it already knows where to go, and I also put email templates in my views directory, and I want to render them as well, and et cetera, et cetera. So in order to do this, all we had to do was just say, okay, if we have a current running request, only then add those things. So this was a very simple change, and it just happened because someone asked, so it works. And obviously the proper run, of course, another fix me. I don't even know what this is. Here we go. And that's it. That's the entire thing. Like it ends here. I'm going to pause here for questions. It's a really good point to pause. Yes?
That hook dot syntax, what's the reason behind that?
Did you raise your hand? No, I'm sorry. What was it? The dot syntax? Oh, it's simply, so I'll just open this up and repeat the question. So your question was, these dots, you mean?
Yes.
Is there a reason to have these dots here? So these are kind of like namespaces in a way, not like actual class namespaces, but sections. So we know that this is an engine. The engine, there is a specific one called template, and then inside that there's before render. If I give it this name, well, it's clear for you. In the code, it's kind of just one big pile of names. But instead, we wanted this pile of names to actually be ordered in a way that we can think about them clearer.
But it's still a symbolic subroutine then?
No, it's not a subroutine name. It's just a string. So if I look up this string, let's take this over here, copy this here, and I'll search for it. You'll see that we call this explicitly as a string. So it's just a visual indicator for us. It doesn't actually create any kind of real structure.
Yeah, I guess the part that has me confused is where does this resolve to subroutine then?
So when you register a hook with the keyword hook, we add an object. We add a hook. How do I clarify this?
I get you. No, I think I get it.
Let me write something. Okay, you call this. Can everyone see this code? Is it clear? Okay, so you call this, okay? What we need to do internally is say, okay, Yo wants to create a hook, a before hook for something. So let's create a before hook and we'll store this sub, and we need to know what before is. So it looks over all of the aliases that exist and resolves before to something. And then it registers in the app, it has a hook storage, and in the hook storage under the appropriate name, this is an alias, under the appropriate name that this resolves to, it saves this sub. And then at any point in time, someone can execute that hook. What you see here is an example, of executing a hook. So someone somewhere has written the code hook, engine, template, before, render, sub. Someone had written this somewhere in their code. And when they wrote somewhere in their code, we stored all of this. When you call execute hook, it looks up the hook storage and says, well, I want to see if there are any hooks for these, and I want to execute all of them, because you can register multiple ones. And if we take a look at this, we can see that this is an alias to this. So someone at the same time might have just called this instead. That's also possible, because these are aliases. So when they registered, it resolves them, and then actually registers them under their proper name. That's why you can only execute a hook under its proper name, because we don't look up aliases when you execute. We only look up aliases to resolve when we register them. So you actually save an operation there. And interestingly, when you register a hook, that resolution, it all happens during load time. So you only pay for this resolution and these aliases, you only pay for it when you load the app, because then it resolves it, stores it, and that's it. And here there is no resolution happening. It's a very clear key for a hash. Okay? Would you like to look at the execute hook subroutine to see how it does it? Oh, we have all the time in the world, because I don't know how much time we have. So anything that wants hooks gets to use this role to basically say, I would like to have hooks. And you have a storage here of all the hooks. And execute hook. Oh, it does look at the aliases. I'm sorry. Why does it look at the aliases? Yeah, I guess it does resolve hooks here. This is a point of optimization. We could optimize this away. And then it just checks that you have the hook and that it's okay, and then it will execute them one at a time. Okay. Does anyone have any other questions? As you can see, I do try to answer them. No? Yes?
I understand the question from the user about how to display stuff more
how? I didn't fully understand what you meant.
I mean, you can put in your route stuff into to the tokens for that. But also data put a lot of stuff to the.
Oh, okay. Yeah. So, okay, cool. Let's see this. So, okay. Clear up a bit. Where are we here? Okay. So when you create a route, let's start digging through all this. I think we're going to see it very clearly. So we'll start with. We started with the answer 2, and of course, what do you do when you finish writing an app? You finish with one, and when you want to run it, you actually run the app.psgi, and the app.psgi runs toApp, right? Does anyone remember the toApp? At least some hands, right? Okay, good. So what the toApp does, we talked about this. It's right over here. The toApp creates a router. So what happens is that it creates this app that has an internal router over all the apps, and then it serves it to your web server of choice, and your web server of choice just runs it every time it needs to serve a request. So let's take a look at how toApp looks like. If we open the DSL, I'm going to go all the way from the DSL that actually has toApp, and I'm going to search for toApp. What you see is that it goes to the current existing app, and it says, please create an app from this. So we can do the same. Let's go to the class of the app, and let's, there we go. And let's look for toApp. And here's the subroutine that he's going to call. And you can see we clearly marked it as the dispatcher, just to make it easier. So, when you call toApp, what it has to do is create that entire dispatcher for you. The first thing that it does is lazily build all the engines. The engines don't actually get built when you create them. We try at least to build them as late as possible. This allows you to add as much configuration as you can beforehand. And then you call toApp and it's like, all right, we're building this thing. And then it calls finish. And if we take a look at finish, I'm just going to split the screen here so we could take a look at just finish itself. What you can see that finish does is register all the route handlers, compile all the hooks, and then adds plugins, and that's it. So, register route handlers. I'm going to close this for now, we'll get back to it. Register route handlers, when you call toApp, adds at the end of your app additional routing code. The additional routing code is defined by route handlers, which is an attribute. And you can see here that the default in the configuration, when it builds the default configuration, it will add to them and say the default one is autopage. So when you finish an app, you call toApp. It has a key that says, I want to turn on the autopage file handler. You can also eliminate this. I guess this is getting confused a bit here with the defaults for something. Core handler autopage, which actually registers a route at the end. This is how autopage is done at the end, because we add it at the end when we finish the app, when you call toApp. So you serialize everything and then it says, okay, now add all of the delayed handlers that have to run at the end. This is where we used to serve the static files. The static files are actually now served, they're served by a middleware. I think you'll see it. Okay, so the actual PSGI app, if you've read the PSGI spec, is simply a subroutine. That's what it is. This is that subroutine. And what we have to do is implement a router inside it. First thing that we check is validating the request methods. And then we will simply dispatch your request to a proper dispatcher, which is implemented in sub-dispatch, and the result of which we will serialize to a proper PSGI result, and then that gets served back. Right here, return response. Here, once we created this PSGI app, we will wrap it with stuff in order to give you some extra things. First one is fix missing body and redirect. Another one is the static, if you have static handler turned on, which is the default. And we also apply something that is called a middleware head, which basically provides a head method for everything. And that allows things to be served before it actually has to call to the dispatch. So if something can be served earlier, that's usually better. We won't have to crawl the entire tree, we don't have to check this against every route. But let's take a look at this crazier part. Dispatch part is probably the most important part, and it's also the one that we want to optimize the most. There's still a lot of room for optimization here, but we need to retain a lot of compatibility. So this is gentle, and we do a lot of work here in order to maintain that compatibility. So we can't optimize everything away. We prefer to have that compat built in. So what we actually have is building a proper request. You can also call it with an internal request, but by default you will build a proper one. This internal request is actually, if I recall correctly, it's only to support when you call dance instead of to app. And there are a few things that are slower because of this, but we prefer that because then we won't break other people's code. This is the actual loop that goes over everything. There are multiple ways to write it. You can also write it this way as well in Perl, and then you can dispatch again to a block. It's kind of, Perl has some interesting things in it, but we write it in a more simple way, where it literally goes over every single route, tries to match it, and if it can match it, it starts setting up all the parameters for it. This is again checking for internal sessions if you call dance instead of to app, and then it dispatches to the route. What you see here, the with return, which is also in charge of some annoying behavior in very specific edge cases. What it actually allows us is, this small part allows us to have some keywords actually return for you. So if you've ever noticed that when you call send error doesn't continue running your code. Like you can't run code after send error, because as soon as it's triggered, it returns for you. You don't have to call return send error. When you call redirect, it exits. That's it. When you call forward, it exits. That's it. It doesn't continue running code for you. You cannot call that. When you call template, the code continues running, so you usually do return template. But the way that the others work is that we're using this module. And this module allows us to jump back up from a subroutine call, which is pretty crazy. And it implements in two ways, because one is not good enough. Okay, well actually it implements in two ways, because one is pure Perl and the other one is using XS and the Perl interpreter better. So if you have C and you can compile stuff, then if you have a GCC and you can compile stuff, then you can install a module that will do it in XS, and then it's faster. But if you don't have that, that's okay. There's a pure Perl version implementation. That's why it has to. And the dispatch route actually has to just call your route. If you look for it, you'll see that it executes hooks before request. This is the before hook, by the way. And it executes the route. And this executes specifically, executes your sub when you call sub. Actually, it goes to the route object, and the route object executes it. But it's almost as good. Okay, so I think I went over quite a few things. I might have made things worse, I might have made things better, but I think at the same time, you can see that the code here is not like indecipherable. There are no really weird characters. There are some things that are more complicated to understand, but there are some things that when you look at them, they're not complicated because they really are simple. In some cases, you look at it and you say, wow, this doesn't make sense. Sometimes it doesn't make sense. Maybe it's for compatibility, but maybe it's just because no one looked at it and said, I could do it differently. And maybe it would be faster, or maybe it would be more capable. This code has a lot in it, and we're not enough developers to see all of it. So if you actually see parts of it and you go, I think I can do this better, raise a pull request, raise an issue, talk to us, and we'd be more than happy to sit with you to work it out or to improve it as you see fit. And there was one example of a ticket opened yesterday of like, I don't know why this template doesn't work the way it should, but I think we should do this. And Person there, thank you. And you raised the ticket and said, I think we can do this. And the only response I had was, yeah, you're right. And let's make that change. So that's it. Does anyone have any questions? None at all? Really? Really?
Where's the next release?
When's the next release? So we're getting into a proper cycle now, I hope. I always promise this. We now have a different person releasing, so that's good. Jason Chrome is releasing all of the dancer releases now, which is really, really nice because he tends to maintain a better schedule. I'm thinking of adding the route naming in there before the next release. We don't have a lot of things going on. If you actually open the changelog here, you can see everything that's going on. And I cleaned up something yesterday night, and this was a cleanup as well. There isn't a lot going on for the next release, as you can see. So the last release fixed something. This is a bit faster, actually. One before that did a bunch of stuff. But the next release, I'm not really rushed to take it out, but we can still do it over the weekend.